This is Mario. Golf isn't just a sport to him, it's a passion, but recently something has been holding him back.
Mario is very responsible when it comes to taking care of his clubs. He cleans them after each round and he makes sure they do not bend when storing them.
Despite being less than a year old, this driver is already showing signs of failure. The team took a closer look and found that it wasn't just wear and tear, it was fatigue failure. First, I saw a crack on the shaft. When I hit balls, they went all over the place and I could not predict my movements. Then I started to hear the club crack when I was transitioning on my downswing and hitting the ball. After repeated use, the carbon fiber sleeve on the outside of the shaft started to peel back, and the graphite interior had a crack which started to form. This crack began to grow and propagate throughout the shaft, at which point the shaft started to bend after each hit and on my backswing. Then the crack grew enough to where the failure occurred.
Fatigue failure is the progressive and sudden fracture of a material caused by repeating or fluctuating stresses, even if those stresses are below the material's ultimate strength. Over time, small cracks form and grow until the material breaks unexpectedly. It's important because fatigue is a major cause of failure in engineering components like aircraft wings, bridges, and rotating machinery. Safety and reliability are critical. Identifying and preventing fatigue helps avoid catastrophic failures and costly repairs.
Back to the golf club, the team used fatigue failure principles to understand why Mario's driver broke early. They found that repeated stress led to crack growth over time and estimated the number of cycles to confirm fatigue as a likely cause.
When analyzing the physics behind Mario's golf swing, we can determine that he applies a force that causes a bending moment, which in turn causes bending stress along the shaft of the golf club. We calculating the bending stress by first calculating the moment that Mario applies, that being 351 Newton meters, then the moment of inertia using a diameter of 0.0085 meters and using a distance from the neutral axis. This yielded a value of 5,834 MPa. Using the predicted number of cycles, that being 20,300 cycles in a year, we were able to graph it onto an SN curve using an ultimate strength of 7,000 MPa and an SE value of 3,500 MPa. After carefully graphing this, we found out that the point at which the graph presents the data is outside the safe zone, that being the failure zone where the golf shaft would yield.